last period we already discussed about the resonance effect. Resonance effect is the redistribution of pi electrons and it gives the different structures. This canonical structures is called as a resonating structure, and when we draw the combined resonating structure, it is called as a resonance hybrid structure. Now today we will discuss about the application of structural effect. That is, we discuss about the application of resonance and their structural effects. For this, we consider the example here. Phenol is acidic as compared to cyclohexanol. Now you know very well about this. The compound which donate the H plus ions easily is called as strong acid as per the Arrhenius acid base theory. Now phenol. Now suppose you come here, phenol it dissociates and it gives H plus ion and form phenoxide ion. This is phenoxide ion. At the same situation, cyclohexanol dissociate and gives cyclohexyl oxide. Now here phenoxide as well as cyclohexyl oxide both are conjugate base. And the strength of acid is depending upon the stability of this oxide ion, either phenoxide ion and cyclohexyl oxide. Now we will discuss here the stability of phenoxide ion with the help of resonance. This is phenoxide ion which is generated by removal of H plus and is conjugate base. Now here in this case these lone pair are shifted towards the phenyl ring and form the next structure. This is the example of plus R effect. Now this negative charge is delocalized in the phenyl ring and lastly it forms the original structure. Means this phenoxide ion shows four resonating structures through plus R effect, and this is resonance stabilize. Resonance stabilization means this conjugate base is stable only due to the plus R effect of oxide ion. But such type of resonance is absent in cyclohexyl oxide, and here this is less stable because there are no R effect, and hence this reaction become reversible and it forms again cyclohexanol, and that's why here phenol is more acidic as compared to cyclohexanol. Here aniline is much weaker base than cyclohexyl amine. Now base, which compound is called as base? Those compound donate the lone pair of electron to H plus is called as base. Now here when we consider the aniline, NH2 group shows the plus I effect. NH2 group shows plus R effect. and here negative charge are delocalized in the phenyl ring. Now it shows one more resonating structure. And lastly, it forms the original structure. Now suppose we give a number to these different structures. Now here, due to the plus R effect, these lone pairs are engaged in the resonance. But what is our definition for base? The compound which donate the lone pair of electrons to H plus is called as base. And in this case, due to the lone pair on nitrogen is engaged in the resonance, and hence lone pair on nitrogen are not available for donation and due to this plus R effect reason, aniline is much weaker base. Now when we compare it with cycloaxial, now when we see the structure of cycloaxial, here there are no R effect. No R effect. Beside this, it shows plus I effect, and hence the lone pair on the nitrogen is available each time to donate to H plus, and it forms salt, and hence the cyclohexylamine is stronger base as compared to this aniline. Now we will repeat here. Base is donate the lone pair of electron to H plus ion, but in this case in aniline, due to the plus R effect, this lone pairs on the nitrogen is not available here, because they are engaged in the resonance in the benzene ring for the donation, and hence aniline is much weaker base. But when we consider the cyclohexylamine here, there are no resonance effect. Besides this, there are plus I effect of this ring, cycloaxial ring, and this lone pair on this nitrogen is available, for the donation to H plus, and it forms salt and it becomes stronger base. Now we will see next example. Now we take the example of amide. Amide, even though contain NH2 group, is behave as a neutral compound. Now we will see the structure of the amide group. This is acetamide. Now, as per the acid base theory, those compound having NH2 group, having the lone pair on the nitrogen, and it donate to this lone pair to H plus and form salt and consider as a base. But what happened in this case? Even though it contains NH2 group, it is behave as a neutral. Now we will explain here. See what happened here. The lone pair on this NH2 group shows the plus R effect. And here these lone pairs are not available for donation and hence this amide molecule is considered as a neutral compound. Now suppose we take the reaction at practical level. No reaction, and hence this acetamide is neutral in nature. Practically it is neutral. So we discussed today the application of structural effect related to the resonance effect. We discussed 3 examples. Phenol is acidic while alcohols are neutral. Second one is aniline is much weaker base than cycloaxial amine. And third one, amide even though contains NH2 group is behave as a neutral compound. Okay, thank you.